Welcome back. So now we have successfully formed a document term matrix and we also understand what it is. This document term matrix is at the heart of many text mining algorithms, also the ones that we are using in this course. However, where we left off in the previous slide is that we found out that the most frequent words were probably not the most describing words. Therefore, there are several techniques to make the document term matrix or the bag of words model more effective. One of such techniques is to remove very common words, also known as stop words. For example, in previous we showed that the most common words were of, the, as, and is. I mean, these words are not very descriptive, so before starting the real analysis, they can be removed. Another thing that you need to do in the exercise work is that you need to remove words that are too frequent in your particular text data. A good example of words that are too frequent in your data are the search terms that you use to search for those documents. This is obvious as you use those search terms to find the documents. Then in the set of documents you have, those terms will automatically appear. Therefore, they can and should be removed before proceeding with the analysis. Other common techniques are to remove words based on frequency or apply different weighting criteria such as TF-IDF weighting. Now, let's go back into the R and see how it looks. Okay, back to R. So I'm in the file initialize.r, which you should always run before you do anything. So I simply select all and click run. And now everything should be working correctly. So you might remember that last week we downloaded data regarding continuous integration. However, the number of papers for continuous integration are not ideal for demonstrating the text mining capabilities. So I'm using all the articles from Transactions on Software Engineering, which is one of the leading software engineering journals. And I have previously executed this query and it had returned to me over 3,000 articles. Now I will simply clean up this data that I have previously fetched. So I set up a new file name. Then I go a bit lower here on line 43 and load the dirty data file. And now I just do the cleanup and saving. I select the rest, execute and hope that everything goes well. Okay, it seems to produce no error messages, so I assume that everything went correctly. Okay, now I have the Transactions on Software Engineering articles on disk, and they have also been cleaned, so they are ready for analysis. In the meanwhile, you may have restarted R and you may continue this on a separate day. So again, I'll start over as well. So I run the initialize.r and then I go to the file dtm and dendrogram clustering.r. You have the same file and you can get it from the GitHub. So first I give the correct file name I wish to load. This is the one I just previously cleaned. So these are the TSE articles. I set it up as a file name and then I load this file over here by executing these 4 lines, and I can see that my articles now contain data with 3,591 observations. I can click and open and see how this looks. I can see it makes sense, and I can see that also all the publication name is same for all. They come from IEEE Transactions on Software Engineering, and I can verify this by going down, and I can see that this is true for all. Okay, now I have successfully loaded the file. Obviously, I also need to load the libraries that this particular file uses on the top. And now I can start working with the stop words. Now those are the words we want to get rid of. So I build up a list of stop words. In here, I can also print this to console. And we can see what happens. So we have 170 something stop words listed here. Most of the stop words come from the stop words library, which is the first term in here. So stop words listed in here come first, and then I put additional stop words, which are simply named my stop word 1 and my stop word 2, that obviously don't make any sense in this case. But you should fill them out with your own stop words. So I simply add them to the end of this list. So now we have a list of stop words that we wish to remove from the documents. And next we simply clean the abstract and the title. And we create the corpus. Document term matrix, and we look into the most frequent words. Okay, so we execute lines 39, 40, and 41. Create the document term matrix, and then we go a bit lower and we plot the most common words, as it is the easiest approach to see what is going on. So this happens in line 61 and 63. Now we should have a figure, and we have a figure shown in here. Let me just slide this so we can see it a bit better. And we can see the most frequent words, the ones that appear over 500 times, as 500 is the limit here. This might be a bit too much, because there's quite many words in here. Let's make it a bit easier and change this to 1000. And now we just replot. Okay, this looks much better. So now we can see, and this is where we come to specific stop words, specific to you. Since I took these articles from the paper, or from the journal Transactions on Software Engineering, I can see that the word software appears in over 5,000 of these documents. Now this is probably a word I want to get rid of. It also appears that the word system and systems are very common, and also paper. So now what I do, I add those words to the stop word list and I rerun everything. Let's see if we are able to get rid of those words. So we put in there software, paper, and what else did we have? We had systems. Okay, let's do it. Okay, now I add those to the list of stop words. Now I have to remember to clean the words in here in lines 32 and 33. And now I recreate the corpus and the document term matrix. And from line 41, we jump back to line 61 and 62 and we replot. And ta-da, we can see that the words software and system are gone from the list of stop words. Or from the list, from the list of most frequent words. Okay, now we have seen how to get rid of the most common words, the so-called stop words. In the exercise, you would probably want to continue this process, as we can still see words that are, well, not very descriptive of the text itself. For example, if we look at the list, we probably would want to remove to. We might want to remove using or used, but I'm not so sure, since this could be an indication of scientific articles talking about the use of computer programs. We definitely would want to get rid of can and also, as they are very common. But what you should understand is that the removal of stop word is it's domain specific, so you should be the final judge of what do you include as stop words and what words you choose to keep in your document for or in your data for further analysis.